Welcome back to the video series on integration and differential equations. Today we're going to take a look at the logarithmic form. Here's our key formula for this section. If we want to integrate du over u, we are going to get ln of absolute value of u plus a constant. Let's take a minute to compare this to the power form. So remember the power form said if we're integrating u to the n, then we get u to the n plus 1 over n plus 1 plus a constant. And we said that there was a restriction on the powers that you could put into this formula. We said n could be any real number as long as it was not equal to -1. And we said that a little bit later on we would see how to handle that case n equals -1. So here we've got the logarithmic form. And so you could consider this the case where n equals -1. U to the -1 is really the same thing as 1 over u. So when you run into this setup where you've got 1 over u or you've got u to the -1 in your integral, you need to use the logarithmic form because the power form does not apply to that particular power. So let's do a couple examples of this logarithmic form. First example. Here's a tip for getting your integral into logarithmic form. Typically we let u equal either the entire denominator or one of the factors in the denominator. So in this example here, let's let u equal the entire denominator. We're going to take u equals 2 plus 3e to the 4x. And as usual for a substitution problem, we're going to calculate du. So let's first calculate the derivative of u. Derivative of 2 is 0, and derivative of the exponential is going to be 12 e to the 4x. So to turn that into a differential, we'll multiply by dx. Now let's take a look up at our integral. So as of right now, we've accounted for the denominator. We're going to be able to write that denominator there as u. And what we're asking is, how can we write 5 e to the 4x dx in terms of du? We'd like to figure out the relationship here. So we're asking, how do we move from this step to this step? Well, one way to do it is to look at this and to say, okay, well, if I want to move from coefficient 12 to coefficient 5, what I'd have to do is multiply du by 5 over 12. So that's the fast way to do it. You could say 5/12 of du is the same thing as 5 e to the 4x dx. Now some people prefer to do an intermediate step here, so if you would like to do the intermediate step, here's what you could do. First, just get rid of the coefficient 12, so move from this step to this step here just by saying du over 12 is equal to e to the 4x dx. Okay, so we've just divided both sides by 12 there. And now it's a little bit easier to figure out how to move from this step to this step. What we want is a coefficient 5, so we'd have to multiply both sides of this equation by 5. So we'd have 5/12 of du is equal to 5 e to the 4x dx. So at this point we've figured out how to rewrite the rest of the integrand here, this 5 e to the 4x dx. We're going to think of that as one object, and we've figured out that we can write that as 5/12 of du. So now we're good to rewrite our integral. So let's put all this stuff here in a box just to keep it separate, and we'll continue our calculation. We'll say the original integral here is equal to the following. The numerator is equal to 5/12 du, and in the denominator we've got u. So that looks exactly like our logarithmic form, and we're ready to apply our formula. We're getting 5/12 of ln absolute value of u plus a constant, And final thing we could do is just put it back in terms of our original variable. So let's replace that u with 2 plus 3 e to the 4x. And there we have our final answer. Here I've recopied our key formula, and I've recopied our tip that we want to let u equal either the denominator or one of the factors in the denominator. So let's try a second example. Let's think about the best substitution to make here. If we let u equal arcsine x, then when we calculate du, we'll take the derivative of arcsine to get 1 over square root 1 minus x squared, and we'll turn that into a differential by multiplying by dx. Now, if we like, we could rewrite this slightly differently. Du is the same thing as dx over 1 minus x squared to the power 1/2. So by making this choice, then we're able to let this arcsine factor here in the denominator, we'll let that equal u, and then dx over the square root is going to represent our du. So by making that choice, we're able to rewrite the entire integral. Now it's totally fine to do a bit of trial and error. Maybe you took u equal the entire denominator, maybe you took u equal just the square root factor, but if you made either of those choices, when you calculated du, you would realize that something's wrong and you weren't able to rewrite the rest of the integrand. With a little bit of practice, you get faster at choosing the correct u right off the bat. So in this case, u equal arcsine x is the only choice here that's going to allow us to rewrite our entire integral. So let's continue our calculation. If we rewrite our integral now, we've got a factor of 9, which we'll put out in front of the integral. The dx over the square root, that becomes our du, and the factor of arcsine in the denominator, that becomes u. So there we go, we've got perfectly the logarithmic form, and we're able to apply our formula. So this is going to be 9 times ln absolute value of u plus a constant, and then we go back to our original variable just by saying u is equal to arcsine x. So there we have our answer, final answer, 9 times ln of the absolute value of arcsine x plus a constant.